Assalamualaikum. My name is Nasriah Binti Mohamad Nasir. Today I would like to present my FYP1. The title is Comparative Study on the Wire and Arc Additive Manufacturing for 5356 Aluminium Alloy with Conventional and Cold Arc Heat Sources. So this is the content, introduction of wire arc additive manufacturing, problem statement, objective and scope of project, literature review, process or method use. This is the introduction. Wire arc additive manufacturing is considered a suitable economical manufacturing process due to its benefit in saving lead time, high deposition rate, low material utilization, and low production and equipment costs. Wire arc additive manufacturing use metal wire among other as raw material and electric arc create through the application of metal inert gas welding, tungsten inert gas welding, and plasma as heat sources. Wire arc additive manufacturing fuse metal wire and layer by layer for molten metal into components to form them by adopting the concept of discretion and deposition. In this project, I have used gas metal arc welding to deposition of 5356 aluminum alloy wire. Gas metal arc welding is faster growing welding method due to its high soldering intensity and the decline in post-welding cleaning. The process of part by layer is accomplished by the deposition of the molten metal wire during cable and arc additive manufacture. Thereby, melting of the wire is achieved by arc welding process. Next is problem statement. The first one, in the previous study, deposition of aluminum alloy is done using rapid prototyping technique. Next, defect will have a negative effect on the surface quality and mechanical properties of the finish as deposit part because of excessive heat. So this is the project of the objective of the project. The first one is to investigate the effect of cold arc gas metal arc welding parameters on mechanical properties and microstructure of 5356 aluminum alloy deposit, and to compare between wire and arc additive manufacturing of cold arc and conventional gas metal arc welding. There were two materials have been used, a wire 5356 aluminum alloy and base plate of pure aluminum alloy. The size of base plate used in this project is 100 mm for length, 25 mm for width, and 10 mm for thickness. The wire 5356 aluminum alloy will be deposited on pure aluminum alloy layer by layer, starting from first layer. Then 4 samples of layer will be recorded, which are between layer 3, layer 5, layer 7, and layer 9. To identify the mechanical and microstructure properties, hardness test and secondary dendrite arm spacing will be used. Next is literature review. There is some of the article that I found from the internet, and this is the most related topic with my topic. The first one is microstructure formation in wasp alloy multi-layer build following direct metal deposition with laser wire. That citation by NIS HUSSEIN ETL 2014. Next is parameter selection for wire arc additive manufacturing process. Citation by LM WAS ETL 2018. And the effect of gas metal welding process on different welding parameter. Citation by Izzatul Aini Ibrahim ETL 2012. Methodology. So this is the flowchart of the project. The first step, I have to identify the material used. The material used in this project are wire 5356 aluminum alloy and base plate of pure aluminum alloy. This is the chemical composition. between of the two material and the mechanical properties of the wire filler and base plate. The dimension of the base plate that will be used is 10 mm length, 25 mm width, and 10 mm thickness. Before the deposition, base plate were washed in alkaline water dried in air, which was followed by mechanical cleaning and by degreasing with acetone immediately before usage. Design of experiment. In this project, I have used design of experiment to analyze the data of the experiment. It will be used in analysis to evaluate the optimum welding speed and the welding current. It provides a minimum amount of heat input for specific base plate thickness, a particular welding procedure, and minimum electrode diameter. Thus, design of experiment help planning, screening, optimization, and verification. To get the analysis, I use Minitab software to generate the data. There were three methods that can be used for design metric, which are full factorial, Taguchi method, and response surface method. I choose to use full factorial method because factorial design is used for conducting the experiment as it allows study of interaction between factors. In full factorial experiment, response method of the interaction. In a full factorial experiment, response are measured at all combination of experiment factor level. As in my project, the full factorial optimization of 5 samples of experiment, arc voltage, arc current, and welding speed have been chosen as input parameter, and weld width of deposition is selected as output parameter. In the previous study, there were more articles deposition of aluminium by using conventional additive manufacturing, while in my study, I will use cold arc and will compare the result with the conventional technique. Basically, the new metal inert gas and metal active gas welding process take advantage of a new type of highly dynamic inverter switching combined with very fast digital current control. For example, the figure compare the waveform of the conventional and the cold arc process. The first two steps are similar to conventional short circuit during the arc burning phase. The electrode approach the workpiece with the current and voltage maintained at the required steady level. In my experiment, 5 samples were used to build the wall structure by deposition from layer 1, layer 3, layer 5, layer 7, and layer 9. This is the work planning. The full factorial and analysis using the design experiment system to determine the effect of the suitable parameter on the microhardness. Microhardness measurement will made along the length of layer 1, 3, 5, 7, and 9 layer build. Comparing the analysis between deposition by cold arc welding and conventional technique of welding, and build another complete of block wall after got the suitable parameter of deposition. As a conclusion, the accuracy and deposition properties during wire arc additive manufacturing depend on materials characteristic. The suitable parameter of deposition will produce a high quality of weld bit, and the parameter that contribute the high percentage of the gas metal welding process is power input, which are current and voltage. For the best temperature suggestion is with the low heat input power. And my expected outcome is get the suitable parameter for deposition of aluminum alloy in terms of arc current, arc voltage, and speed of welding. Get the effect parameter on microstructure measurement for every layer, which is layer 1, layer 3, layer 5, layer 7, and layer 9, and produce high quality of surface for wall structure for all 5 samples of welding. That's all from me. Thank you.